In this question, you have a man pushing his child in a grocery cart. So here's the grocery cart, there's the child, there's the wheels. Okay, so there's the grocery cart, and you've got this person pushing the grocery cart. So the question tells us that the total mass of the cart and the child is 30 kilograms. So this is 30 kilograms. We also know that the force of friction on the cart is 15. The question is, how hard does the man have to push? And it tells us that this cart is going to accelerate at a rate of it is 1.5 meters per second squared. So the first thing we have to do is make the force diagram. So if the cart is going to be moving forward, that implies that the man is applying a force. Now, I know he's applying the force over there, but it's okay. We're always kind of putting our arrows so that they radiate outward from the object. So we have an applied force there, and we also have a force of friction backwards on the cart, right? So there's the force of friction. I know the value of friction. They tell us it is 50 newtons, right? But we don't know this. This is my unknown. So how do we go about solving this question? The first thing we do is what we always do. Draw a free body diagram. We can choose our sign convention. Let's pick, in this example, the direction forward as positive. Therefore, backward is negative. And we'll start the same way we always start with our F net equals MA. MA equals the sum of the forces. I write this every single time. I don't necessarily expect you to, but just to keep in mind that there's two ways to think of the net force, as the mass times the acceleration and as the sum of the forces. So what are the sum of the forces in the horizontal direction? We have FA forward and friction, negative FF backwards, right? So now, what do we know here? We know the mass, we know the acceleration, we don't know the applied force, but that's our unknown, and we do know the force of friction. So this is a matter of, now that we have generated our equation, we can substitute 30 kilograms times 1.5 meters per second equals FA, subtract, and then we have 15 for the force. And then doing the math, we get 30 times 1.5 is 45 equals FA minus 15. So FA equals 45 plus 15. The applied force is 60 newtons. So he applies a 60 Newton force. It's really easy to make a mistake here with your signs and end up subtracting the 15 instead of adding the 15 and get an answer of 30. So just be really careful when you choose your sign convention and putting the signs into the problem, that you're very careful about what you're